Thank you. Okay, so good evening all. Welcome again to this webinar session. So mine is going to be a short one. I'm actually planning to do some demonstration on basically comparison between just containerization and containerization with container orchestration. So for that, I will be using AWS and Docker for demonstrating containerization for deployment and OpenShift for deploying application using containerization and container orchestration. Okay, yeah. Thank you, Mentor sir and Amal sir, for sharing that opportunities in cloud and DevOps in this AI era, and also sharing the importance of attending trainings and getting certified. So before this demo, I would like to go through some, very basics of cloud and DevOps, because it's a mixed audience. So I would start with what is a cloud in a single sentence. We know electricity as a utility, gas as a utility, or water as a utility, right? So same way, when we need computing power, of course, if we are in AI era, we need GPU for AI computing. So it's a delivery of computing, storage, network as a utility. Most of us know that. And based on service model, we can divide into platform as a service, infrastructure as a service, platform as a service, software as a service. We all are familiar with this, especially software as a service like Gmail, Google Drive. Yeah, that's an example of software as a service. So if you are a group of developers, you just need a platform for developing that applications. Yeah, platform as a service. You don't need to worry about that infrastructure. So the platform service providers like OpenShift is one of the example for PaaS. Or if you're completely looking for a virtual infrastructure, yeah, that is infrastructure as a service from AWS or GCP or Azure, or with the Red Hat OpenShift with the IBM. So these are based on service models, and based on service models, if you can just go through this slide, yeah. So there is a comparison. Like in the earlier days, in traditional IT infrastructure, we had to manage all these things. But when it comes to infrastructure, we don't have to worry about operating system, virtualization technologies, power backup, network bandwidth, etc. So we just need to focus on application data, runtime, middleware. But for platforms as a service, everything is ready except our applications and data, and software as a service is completely managed by the service provider. And based on deployment model, so we have AWS, GCP, Azure. Yeah, that comes as a public service. So they offer the services like computing, storage, network in a public level. But I think, yeah, Amal sir already mentioned that for those like banking sectors, defense sectors, insurance sectors, they want to keep their data geographically in their custody. So they also need the features of cloud. So for them, private cloud. So we have the combination of this public and private. We call it as hybrid. So this is a summary of cloud computing, like on-demand service, broad network access, high availability, rapid elasticity. So these are the main features of using cloud computing. Okay, so that's about cloud computing. So when it comes to DevOps, so it's a combination of development and operations. So basically, it's a collaboration of development team and operation team. It's not it's not a product or a software. It's a methodology. So DevOps is a set of practices that combines software development team and IT operation team to shorten the development life cycle. So basically, the objective of this DevOps is to deliver the product on time or before that. So these are the challenges before DevOps. Like before DevOps, we had different methods like waterfall method, agile method. So if you discuss about the challenges, separated development and operations, because they just work for their focus or their objectives only. So developers just develop the software, and operation teams just focus on, when the source code is ready, or when the developers delivers the source code, just runs in the production servers. But actually, we need a single objective, like deliver the product or software on time. Incomplete documentation, operation struggle, delays in releasing software, blame came because developers and operations, they blame each other because there is no collaboration right before DevOps. Ongoing fixes. So these are the challenges faced before DevOps. But with the DevOps, so if you can see the screen, so it's a continuous flow. It's an infinite flow, right? So once planning is done, source code. So source code we keep in a Git or some kind of source code version control systems. Then developers develop the source code. We keep in the version control systems, and we build using building images by comparing the source code and builder images, then test it, then release, then deploy, operate, monitor, plan code. So this process continues. So whenever if there is any modification has to be done, so make the changes in the code, rebuild, test it, release, deploy, operate, and monitor based on the feedback. Again, make the changes. So when it comes to the demonstration, I will show you that first I will deploy a source code, and then I will make some changes with the source codes, and that will replicate, or that will make some changes in the production servers. So this is DevOps, and benefits of DevOps, like faster time to market. That's a very important. Improved collaboration, increased efficiency, better quality and reliability, scalability, because it's easier to scale operations and infrastructures to handle large number of complex systems. Okay, especially, I mean, in this DevOps tools, DevOps is a methodology, and we use DevOps tools to manage this cycle. So in that, we already heard about the containerization and container orchestration. So I just want to compare the containerization with the virtualization. So virtual machines actually takes time, right? So if you are if you have experience with virtual machines, it takes minutes to launch a virtual machine, right? But containerization is actually an isolation of process running in an operating system. It takes seconds to run it. So, and compare with the virtualization and the containerization, containers, because containers are the product of containerization process. So containers takes very less amount of resource, but virtual machines takes more. So when we compare with virtual machines and containers, VM isolates the hardware, but container isolates the process. So container is a lightweight, standalone, and executable software package that contains everything needed to run a piece of software, including code, runtime, system tools, libraries, and settings, etc. So containers uses very less amount of CPU, memory, and the rest of the resources. So in my first demonstration, to do the containerization or to create a container, we need container engines. So the popular container engine called Docker. So I'm going to run a Docker client in AWS machine, and using that container engine, I'm going to deploy a simple web page. So to save the time, I already launched that instance in AWS. So this is a virtual machines. So this is a benefits of using cloud, because I don't have any Linux machine in my system. So I launched a virtual machine Linux server in AWS Mumbai region. And in that, I already installed Docker, the container runtime, and container also launched. So using Docker PS command, I can show you that the container is running here. And the output of the container is, I mean, the actual page is here. I will share the link as well. So this is the content of that page. So if you want, I can paste that IP address in the chat box. Yeah, from your system, you can access this link. So you're actually accessing the page which is served by a container. So it's a simple page. It's on cloud and DevOps engineering with hands-on training, and you can read this content as well. So what I'm going to do is there is a word like Valin. So Valin is actually a subsidiary company of ipsr. So I'm going to make change, like instead of Valin, I'm going to make it as a ipsr. So here I have the index.html file, or that content file which serves that web page. So I'm going to make the change here. So here, instead of Valin, I'm changing it to ipsr. Okay, so which means I'm making some change in the source code. So just think like that way. So I'm making some change in the source code, and after that, I'm applying that index.html into the container. So this is the container ID. So you can see from here, container ID. So I'm replacing the current index.html in the container with the index.html, which I created locally, I mean, in this instance. So now that is successfully replaced. So if I refresh this page, so you can see that the course from Valin changed to ipsr. So you can verify from your end as well. If you just refresh the page, the Valin changed to ipsr. But what I'm trying to say here, it's just containerization only. The page is served by just a container, a single container. If I stop this server, or just in case if the container crashes, what will happen? So I'm manually stopping the server. Docker stop. Okay. Page is not displaying. So just imagine something happened with the container and the page is not displaying. So this is not acceptable in a production or in live environment, right? Maybe for developers side, it's okay, because developers, they're not bothered about load balancing and auto scaling. So they just need to make sure that that application is running in a single machine. But as we are platform engineers, so we have to make sure that our applications are highly available. So we need containerization plus container orchestrations. So we need actually a container orchestration. So that is what I'm going to explain, and also I'm going to show you the demo on orchestration, container orchestration using OpenShift as well. So without container orchestration, scale-up services, we have to manually manage, fixing crashing nodes, complexity for running new stuff in production increases, human cost for running services. Scaling becomes more and more difficult. Scaling means based on the traffic comes to the application, we have to manage it manually. Public cloud providers will be more and more expensive. So we need a container orchestration like Kubernetes, and of course OpenShift also. OpenShift, Kubernetes is the container orchestration engine. So we need a self-healing, or we need an orchestration engine which does the self-healing, auto-scaling, load balancing, and make sure that our application is highly available. So Kubernetes is one of the example, the most popular example for container orchestration. So ChatGPT. So ChatGPT is powered by Kubernetes. So just like I mentioned earlier, there are different types of clouds, like public cloud, private cloud. Same way, I know that nowadays the companies are going to implement private AI engines. So for them, they need a platform to run these AI applications. So right, so same like ChatGPT uses Kubernetes, yeah, we can use Kubernetes and OpenShift for running our AI models. And as I already mentioned about OpenShift AI, that is one of the example. If you are a data scientist, so you can design and develop AI models and OpenShift AI, which runs on top of OpenShift, provides the platform for running your application. That means it provides CPU, GPU, memory, storage, networking, etc. So OpenShift is actually a combination of, it's actually a platform as a service, which means it's a combination of containerization engine and container orchestration engine. So Cryo is the container runtime in OpenShift, just like Docker, what I demonstrated earlier. So that is a Docker container engine. So here we use Cryo for the containerization and the Kubernetes for container orchestration. And base operating system is RHEL Core OS. So in next demonstration, I'm going to show you something like I have some source code in Git repository. Okay, so I'm going to build an application using that source code. That means compiling that source code with the builder image, and I'm going to deploy that application in OpenShift with load balancing and high availability, which means if a large number of users access the application, or if large number of traffic comes to the application, it automatically scales out. And also it does the load balancing, not like the demo which I showed earlier, because in the earlier demo, when I stopped the container, the application stopped displaying the pages. So I have that cluster dashboard here. Yeah, this is my OpenShift cluster dashboard, which is running in AWS. To save the time, I already launched the application. And this is the page. Okay, so this is the page. I'm pasting the link in the chat box for your reference. If someone can confirm me, please, if you can access this page from your end.
Yes, sir. Accessible.
Okay, yeah. Yeah, the same content what I used for the first demonstration. So here also the word valid, right? So I'm going to replace here and here. And this is the source code. Sorry, let me open the Git. Yeah, so this is my source code. So using this source code, I already deployed that container using OpenShift. So now I'm going to make changes. So currently you can access the web page and you see that val embed, right? Val embed there, right? So I'm going to replace. Yeah, I'm going to search for valin and replace with ipsr. Okay. Yeah, it changed to ipsr. Now committing changes. So there is no change, right? There is no change at your end till it is valid. So what I had to, either I had to do this automation, like whenever there is any change in the source code, automatically redeploy, or now I'm going to manually redeploy. I'm going to build section. So build is nothing but building the source code with the builder image. This is a Node.js application. So I'm going to rebuild. So when I say rebuild, it is actually creating a new container. Okay, so it is actually creating a new container using the new builded image. And once that is successful, the existing container will be destroyed. Okay, so I'm going to start the build. And while building the new image, you can access the existing content. You can verify that. The rebuilding is happening, but still you have the access to the application container or application server. But it says valid, so that will be replaced once this completes. Okay, now that is completed. So in a moment, that will be changed to ipsr. Yeah, it's changed to ipsr. So if you can refresh from your end, you will see that value changed to ipsr. So this is actually a simple demonstration of continuous integration and continuous deployment. Or it's a best practice of DevOps methodology. So I made some change in the source code, and I rebuilt the image, and using that image, we created a new container. And once that new container is running successfully, the existing one destroyed. And also, I want to show you that self-healing feature of this orchestration engine. Self-healing in the sense, in previous demonstration, I deleted that container, right? But nothing happened. I mean, new container is not created automatically. But here, so this is the container. Okay, this is the container. And what is the container ID here? TWL64, just to give a reference, like this is the container ID here. I mean, the current container ID. So in actions, I'm going to delete this pod. Okay, I deleted that container and automatically new container created. So actually I could delete the container, and if you check from your end that if you refresh the page, yeah, there will be a little delay because there is only one container. So what I can do is I can increase the number of containers in the load balancer, because by default the load balancer is configured. So currently there is only one pod or one container serving. So if I want to load the balance, balance the load, I can increase. So now I increase to 3 ports. So which means all these traffics are load balanced using these 3 ports. So 3 ports serves that. Yeah, so it's perfectly running. And this is the main advantage of using container orchestration tools like Kubernetes and OpenShift, because there is no downtime. So 99.9% or even 100% availability we can make sure by configuring load balancing and auto scaling. Okay, so that was a simple demonstration of DevOps methodology using containerization and container orchestration in Red Hat OpenShift. So generally, I can say in this platform, we can run applications. I mean, like normal, traditional applications, and also the AI model applications. With the help of OpenShift AI, we can run that as well. Okay, so so far we discussed about opportunities, advantages of the cloud and DevOps and all. So if you have a question like where to begin or how to begin your cloud and DevOps journey, already Minter sir and Amal sir mentioned about that Linux operating system. Yeah, I want to say that again. Like even though in this AI era, or all these new technologies are running on top of Linux platforms. Most technologies. So what I recommend, or what we recommend, learning Linux operating system, because this is the foundation for all these new technologies. So learn the Linux operating system, especially Red Hat Enterprise Linux, which is built for AI. And after learning, or with Linux, you can learn the basics of networking as well, because when it comes to cloud infrastructures, yeah, basics of IP addressing, then networking and all, it's very important. So along with Linux, learn basic networking. Then the tools, DevOps tools, the tools for planning, coding, building, testing, releasing, deployment, operate, and monitor. So we can start with containerization. So I already gave the demo on Docker. So you can start with Docker, Podman, like different container tools, then container orchestration tools like Kubernetes, OpenShift. Then cloud platforms like AWS, Azure. Then automation tool, of course, because you may know do one task in one system, but if you are asked to do that task in 100 systems, so doing that task in 100 systems is a hard working, right? So we are actually looking for smart working, right? So using the automation tools like Ansible, if the task takes 10 minutes to run in a single system, the same time is enough for running the task in 100 systems, because you actually gives the instruction to the controller and saying that do this task in 100 systems, and the Ansible controller does that automation jobs. So the basic thing is learning Linux and networking, then DevOps tools like what I mentioned here, and also the OpenShift platform, because it's a platform as a service. On top of this platform as a service, example like if you consider this OpenShift as a mobile, just to understand the concept, right? Okay, so if you consider this OpenShift as a mobile, into OpenShift you can add features by installing operators, just like installing applications into mobile. So OpenShift AI is actually an operator which is deployed on top of OpenShift. So what I'm trying to say is, even it is a AI model application or it's just a normal software applications, so it actually needs the networking, computing, GPU, storage, etc. So OpenShift as a platform as a service can provide this platform for data scientists for developing and deploying their AI models, and for normal developers, they can develop that source code and apply using the development and deploying methods. The same thing what I demonstrated earlier. So this can be run in your laptop or data center. I mean, in our own data center or in OpenStack, it is actually a private cloud from Red Hat, or it can be on top of AWS or Azure or GCP, Google Cloud. Okay, so to summarize, I already mentioned where to start. So just for your reference, I can share this web page as well, because those who are looking for where to start and what are the courses teaches you to learn about enterprise Linux, enterprise automation using Ansible, then cloud platforms like AWS and Azure, and basic Python programming also recommended, because for example, like Ansible modules are written in Python, and also the basic idea with Python programming is recommended for DevOps engineers. Then DevOps tools, in that DevOps tools, you can start with Git, Jenkins, Terraform, and containerization and container orchestration tools like Docker, Podman, Kubernetes, OpenShift, etc. And with that, you can begin, and also for the level 2, you can go with certification courses like DO 188, DO 280, or Kubernetes certifications like CK. And with that, Linux administration and automations, of course, as Amazon mentioned, certifications like RHCSA, that is for Red Hat Certified System Administrator, and RHC, that is for Linux automation using Ansible. Then certification like DO188, DO284, OpenShift platforms. Okay, so just for your reference, I'm pasting this link in the chat box. Okay, yeah. So yeah, so that's it with me. I'm done with my session. So any questions?
Thank you, Szen. If you have any questions for Szen, please post it in the chat and we'll take it. Few of the earlier questions, Amal Mate has